So you can see a typical grid connected solar power plant system SLD block diagram. So this solar PV modules will generate a DC power. PV modules always, wherever you go in all over the world, modules will generate DC power. Some of the modules are coming with inbuilt inverter. Uh, right now, it is not available in India. Some German companies they are doing. Micro inverters are there, so they set up that micro inverters in the module. So that directly give the AC power. So that is different concept. So here the PV modules are mostly our right now whatever everyone is setting in commercial market. The modules will generate DC and this is the inverter. It's a grid connect inverter. How what it will do, whatever the coming power from DC, it will convert to AC and it has a synchronizer in it, so it can sync with our existing grid frequency and voltages. This is our distribution panel, you can say, and this is the net meter. So generally, uh, without solar, your house setup will be like this. Okay, up to here without solar. So after solar, it will add here. Okay, we can connect here. So I will explain something. So suppose your residence is required a 5 kilowatt system. So 5 kilowatt solar power plant you install, and your suppose at one particular time, solar. I mean, at peak time we can get maximum 5 kilowatt means we cannot get 5 kilowatt at all time. Solar power will be vary. So max peak sunny hours we can get 4 kilowatt is the maximum power at afternoon time. So suppose your load is 6 kilowatt. So 4 kilowatt solar power will goes to your load and balance 2 kilowatt we can draw from grid. Okay. And suppose your load is only 2 kilowatt and still solar is generating 4 kilowatt. So that excess 2 kilowatt goes to grid export. It will export. So here only the current direction will change. Nothing. Voltage frequency will be same. Uh, 5 kilowatt means single phase power supply. We can get maximum of 20 amps. Suppose if residential house having a 4 amps of load, I mean that means 1 kilowatt, it will goes to that 4 amps here, and the rest 16 amps or whatever excess amps, it will goes to grid. That the time this meter will rotate in reverse direction. That units also we can do. And here you can see multiple cases. Solar on, grid on, load is also load will be on solar. Partial solar light is there, grid is on, solar and grid combination load will be free. And solar off, grid on, so load will be on grid. Solar off, grid off, there is no power supply. Partial solar light is there and grid off, there is no power to load. So in this system, drawback means if grid fails, the system will shut down at inverter level. For that, I will explain a reason. So you can see this is a simple graph. So if you see this graph, this graph is solar power generating graph, power generated graph. So if you set up a 5 kilowatt solar power plant, so our sunlight, I mean our light intensity, how morning it will be minimum. It will whatever 9 o'clock it will 9, 10, during afternoon it will goes to peak. Again it will come down. So same like in power generation also like that. 5 kilowatt if you set up morning 6 o'clock it will start from zero point 0.5 kilowatt, 6 or 7 o'clock. 300 watts, 400 watts, 500 watts, like that it will increase. Around 11 o'clock it will goes to 3 kilowatt or 4 kilowatt. 12 o'clock it will goes to 4 kilowatt peak and it will come down again. So like that power, in this solar there is no stable power. It is depends on sunlight fluctuation. It will also fluctuate. But our resident load is stable. It's a 3 kilowatt load, stable load. So what happens? Uh, Suppose, I mean, in this system, somebody is saying that, sir, if grid fails, why it is not working? Still, there is some energy. So I will put one change over here, and I will run our loads. Means it is not possible. I'm saying. Actually, this in this inverter, there is a one feature called anti-aliasing. Anti-aliasing means what? If reference power is not there, it won't generate. It will stop. It will stop the power generation. Even if you have a good sunny light, if you have a good input from DC also, this inverter won't generate and it won't feed to our loads or it won't give the output. For that, discom people for protection one thing. Why? Because suppose if you are setting your solar power plant to your house and in nearby at your pole, you have a maintenance work. Some linemen will come and they will do maintenance work. They will shut down the power at substation and they will start the work. But your solar power plant will feed the power to that grid means they can get stopped, right? So that is the one safety reason. Suppose somebody is saying that I will put one change over here. If grid fails, I will break the line here. So then I can use only my house. But that is also not possible. Why? Because due to this reason. If you're, I mean, if you are running 3 kilowatt loads, you are watching TV, running AC. So suppose solar is generating 4 kilowatt, fine. Suddenly cloud will come. So power drops to 2 kilowatt. Then what, that remaining 1 kilowatt, where it will take? If grid is there, from the grid it will take. Or battery is there, from the battery it will take. So in this on-grid system, there is no battery. Battery concept storage is not there. So that's why if grid fails, if there is no reference power, this system will shut down. So initially, I told now a lot of people, some who don't have proper knowledge, so they committed client to if you set up a solar on-grid system, it will feeds your entire house 24 by 7 power. So like that, some miscommunicated after installing. If grid fails, this entire system is off. So again, the client comes and shouting on vendors, and you are not given proper system like that. So like that, some situations also happen. But you have to tell if you are going with on-grid system means there is no backup. This system to save your power bill, not for backup. Okay. For backup, another systems are there. That is off-grid systems. Coming sections, I will explain. Off-grid and hybrid also there. Okay. And you can see this is an example. If you for to design a solar power plant. For example, if you for your school you want to set up a solar plant. So school, it is consuming average per 12 months, 12,000 units. And that school have a 7,000 SFT shadow free area. And that school have a connected load of 100 kV. So these are the inputs you got from your school. For example, you can take. So to calculate the system size, first we have to uh, design first their consumption base. So first factor PV capacity based on consumption. So monthly units, monthly average units divided by 30 days divided by 4. Why this is means? So monthly average units, 12,000 units means if you divide 30 days means daily, uh, how much? 400 units. So to get 400 units from solar power plant, what we have to do? So from 1 kilowatt, we can get 4 units. So if you set up 100 kilowatt system, 400 units we can get. So like that. That's why monthly average unit divided by 30 divided by 4. So your system capacity will come. Here it is 100 kilowatt. So based on their consumption, they want to minimize the power generation almost to zero. They want to do means 100 kilowatt setup. If you set up the 100 kilowatt system, then it is possible. Next, come, but to set up 100 kilowatt system, they have a roof area. Next factor that you have to check that area, roof area. So total area divided by 1 kilowatt, how much area is required? So they have a 7,000 SFT uh, divided with for 1 kilowatt, how much it is required? 80 SFT. So it is coming around 87.5. Actually, this is based on layout drawing. If you design one layout drawing, then we can know exactly. But rough calculation for initial proposal, we can check like this. If they have a confidently saying, I have a shadow free area approximately this much. So you can say you can tell like this. You can just divide it that area with the SF 80 SFT. You can know the minimum this much we can set up there. And next connector load. So customer existing connector load is 100 kilowatt, 100 kVA. So we can set up 100 kilowatt. There is no issue. But again here the electricity board will involve. Some states are not allowing 100% on connector load. They are allowing 80 kilowatt only, 80% only. You can see here in AP and Telangana, Andhra Pradesh and Telangana, as per here the discount policy, 80% only they will allow. So we can set up maximum 80 kilowatt. Suppose if you go Karnataka, there 100% they will allow. Even Delhi also 100% they will allow. So as per area, in these three, whatever the highest, we have to select that one. Sorry, lowest one we have to select. So 87 kilowatt, we can select, we can install in Karnataka state and Delhi. If you are in AP and Telangana, it is 80 kilowatt only max. So, so I think you got my point. So I will share this PPT. So you can also check your residence and suppose if you have any business, I mean if you have any commercial office or manufacturing unit, you can check how much solar plant is required based on these three details. Power bills anyway you can get from your residence, you can get, and roof area you can go and visit and measure the area how much SFP you have, and load power in power bill copy you can get. This is another example for residence, you can say. So there is a 370 units per month for one residential house, and they have a 300 SFP shadow free area, and they are connected load of 10 kilowatt. Similarly, 370 divided by 30 divided by 4. So they almost required a 3 kilowatt system. And area wise, they have a more area, 3.75 kilowatts, and their connected load also more, 10 kilowatts. So we can easily install 3 kilowatts.